Alright, back to section 2. Man, can you believe we're already on the 42nd video of this year? Boy, that's crazy. So, since you've been a patient and diligent audience this whole time, I thought I'd take the time to tell you a little bit about myself. What I'd like to share with you today is Me llamo es Joaquin. That was my name in Spanish class when I was in high school. Anyways, now that you know that, let's talk about the intermediate value theorem. An intermediate value theorem is something that's really kind of a no-brainer, and yet it's kind of helpful. So let's break this down first, because intermediate value theorem sounds a little bit daunting. So let's just concentrate on one word at a time. Intermediate. Intermediate just means somewhere in between. And value is just a number. So this could really be easily called the number somewhere in between theorem. And that sounds a lot less daunting than the intermediate value theorem. But, you know, I didn't name it. If I did, I would have probably named it Joaquin. Anyways, what it's basically saying is this. If a function is continuous, remember I said continuous means you could take it from the very, very left and trace it to the very, very right and never have to lift your pencil off the paper. So all of our polynomials are going to be continuous. All of them. And if you know that when x equals a, when x equals a, that y is negative, and when x equals b, that y is positive, well, somewhere between a and b, y has to be 0. You can't go from negative to positive without crossing the x-axis somewhere, and the x-axis means y equals 0. That's really all the intermediate value theorem is saying. It's quite simple, wouldn't you say? So what gives? What's the point? Well, it's going to help us with some zeros. We have this graph here. Is it continuous? By God, it is continuous. Is there a portion where f of a is less than 0? Yeah, I would say that, you know, at 1, y is negative, right? All right. Is there a place where it is positive? Yeah, I'd say at 2 it looks like it's positive. Swell. So what's the big deal? Well, heck, it means somewhere between 1 and 2 the graph hits 0. Yep, it does mean that. That's great. Well, I did say that I gave you a modified version, and that is I modified it so that you could realize that it would tell you that between a negative and a positive it's going to hit 0 somewhere. But the intermediate value theorem actually applies to anything, any value. Okay? If you know that f of a equals 6, f of b equals, I don't know, 10, then you know somewhere between a and b the function is going to hit 8, because 8 is between 6 and 10. All right. So, the truth is it works for any value. Yeah, pardon me, I mean, it's been a long day. I'm making these videos. I'm telling you that my Spanish name is Joaquin. I'm a little bit slow tonight. Bear with me. Anyways, let's use that to figure out where on this graph y equals 2. All right, well, I can see that it happens at some place between -5 and -4. Okay, it's kind of hard to see on here, but let me go back. -5 on this graph happens right there, and you can see that it's just a smidge above 2 at that spot, and at 4 it's right here. So we know that somewhere between 4 and 5 it hits that sacred value of 2. All right, and then we do the same thing on the other side, and we see that it hits, here's 6, and 7 is way to here, so we know that it hits 2 somewhere between 6 and 7. Now this all seems simple to the point of being dumb. Am I right? That's because we had a graph to look at. Normally we will not. We actually use this to help us make a graph. If we can't factor an equation to find zeros, we use the intermediate value theorem to identify roughly where the zeros occur. Okay, so it all seems kind of nonsensical when you have a graph there and you can easily see where it's crossing, but when you don't have a graph and you have to make a graph, the intermediate value is going to help us find where some zeros are. If you plug in f of 1 and it's negative, and you plug in f of 2 and it's positive, you know that it's somewhere between 1 and 2, even though you don't have a graph. So here we go. Let's use the intermediate value theorem to determine the interval where a zero occurs. First, note that the equation doesn't factor. Alright, so also notice that when x equals 0, y equals 1. And 1 is kind of close to 0. So let's try some values close to 0 for x. Let's try 1 and 0, see what happens. F of 1, when you plug it in there, you get 1 minus 1 plus 1, which is 1. Since both f of 0 and f of 1 are positive, the 0 isn't there. So we're going to have to try some other values. Okay, so basically, if you think about this graphically, when f is 0, I ended up with a positive number. When x was 1, I ended up with a positive number. So it's not going to happen in between there. So let's try some other values. It could go down and up again, but let's try some other values. Let's try -1 and 0. When I plug -1 in, I get -1 minus 1 plus 1, which is -1. Woohoo! That means that somewhere between -1 and 0, a 0 occurs. So graphically, somewhere between 0 and -1, somewhere in this region, the graph is going to cross, which is kind of helpful if you're trying to graph it. And that, my friends, is how a bill becomes a law. See you tomorrow.